What's up everyone? In this video we're going to be talking about basic electronic components and circuits. First component up is the resistor. The resistor's main purpose is to reduce current flow in a circuit. You can tell the value of the resistor by the color of the bands. To find the value of a resistor using the colors, you'll start with the first band. In our case it's brown. So brown is 1. Next is black. Black is 0. The third one is your multiplier, so this tells you how many zeros to add. Or in our case it's red, so red is 2, so we add 2 zeros. And our last band is our tolerance, and ours is gold, so it's plus or minus 5% of 1,000. Here I'll just point out the bands on a real resistor. This is what they look like on a 4-band. Probably the fastest way to check a resistor value is hooking it up to an ohm meter, and as you can see mine was a little bit out of tolerance. To create a better visualization of how a resistor works, we used water flowing through a hose, and I crimped down with some pliers to restrict the flow, and as you can see the water slowly dribbles out instead of flows out. This is exactly what a resistor does in a circuit. Next component is a capacitor, and the capacitor's purpose is to temporarily store electrical energy. The capacitor is able to store this energy because it has 2 conductive plates with the dielectric in the middle, and as electricity passes through it, the plates build up a charge and it holds it. I'm using an electrolytic capacitor, so it's polarity based. If you're not careful hooking these up, you will blow up the capacitor. Here I hook it up to a power supply and charge it up to 16 volts, and then I unhook it, hook it up to the meter to allow you to see the charge that it held, and you'll watch it drain through the meter. Here I tried to give a visual representation of a capacitor. So basically a capacitor is like a bladder. So once it fills up with its charge, it holds it. And I tried to do that with this water bottle. So up next is an inductor. An inductor can take electrical energy and turn it to magnetic energy. And it does this by having a coil of wire wrapped around a core material. And when the electricity flows through it, it puts off a magnetic field. So this is an inductor out of a little DC motor. So when you apply voltage, it energizes the 3 magnets and causes it to spin. So that's what turns the motor. So to get a better visual of what inductors do, you can use a water wheel. For instance, a water wheel takes the kinetic energy of water and pushing it on the wheel, it makes mechanical movement. Whereas an inductor takes electrical energy and turns it into magnetic energy. Okay, now we're going to roll into some circuits. The first one up is a simple series circuit. So on the left I have some equations that you can use to break down a circuit. And then on the right I got the Ohm's law and power. So in series circuits, one thing to remember is current stays the same throughout the entire circuit, and you just add up the resistance. Okay, we're going to break down this circuit. So first you want to add up the total resistance. So you take all the resistors, add it up, so we get 16K. Sometimes it helps to draw another circuit with just the total resistance, so that's what it is to the right. Once you get the total resistance, you want to find the total current. So you'll take your 5 volts off your battery or power supply and divide it by the 16K, and we come up with 312.5 microamp. Once you have your total current, you're able to find the voltage drop on each resistor. So what you want to do is go up to your R1 and multiply 1K by the 312 microamps, and you should get your voltage drop, which is for V1 0.3125 volts, and you do this for the entire circuit. Once you get all your voltage drops across them, to check yourself, you can add them up and they all should add up back to 5. If you wanted to find the power draw that this circuit uses, you would take your I total and multiply it by your 5 volts or your power source. Okay, we're going to build that same circuit but on a breadboard. So first thing you want to do is set your power supply voltage to 5 volts. Okay, then I checked the value of the resistors I'm going to be using. I checked the 5K first, and then I went to the 10K, and then I moved on to the 1K. Then I put the resistors in series into the breadboard and checked the total resistance. Then I hooked up power to the circuit and turned on the power supply, and then I was going to measure the voltage drop across R1. After I measured the voltage drop across R1, I went ahead and measured the voltage drop across R2 and R3. So once we measured all the voltage drops across each resistor, I went ahead and put it down here so we get a better visual. Then I moved on to measuring the current. To measure current, you have to break the circuit. What I mean by break the circuit is you pull one leg up the resistor and you hook your lead to it, and then you hook the other lead up to the wire that completes the circuit. So you measure the current flowing through your meter. As I said before, in a series circuit, the current should be the same throughout the circuit, so you'll notice that as I go through each resistor, the current stays the same. So once we got the current calculated, I went ahead and solved everything else and put it here, and we're going to compare it to our calculated values. And you'll see that the calculated and measured values were pretty close. There's some variation in the resistance and in the voltage, but you'll never get your measured exactly like you calculated. So next is parallel circuits. They're a little different in series in that voltage is consistent throughout the same thing. To find your resistance, you can't just add up the resistors, you have to do the reciprocal of each one and then the reciprocal of the total. And then current, you have to take the voltage and divide it by the resistor in each leg. So we want to begin with finding the total resistance. So we break it down and find out that it's 769 ohms. And then once again, for me, it's easier to draw it as a simple circuit like that and then expand it back out when I go to solve it. Once we have the total resistance, we're able to find the total current. So once again, we'll take the 5 volts and divide it by the total resistance, and we come up with 6.5 milliamps. So we can check this by taking our voltage across each leg and dividing it by the resistance and get the current across each one. And then we can add them back up and they should come back out as 6.5 milliamps. So to find power, once again, we take the voltage and multiply it by the total current and we come up with 32.5 milliwatts. So I used the same resistors from the last circuit, so I already know their values, but we still need to find our total of this circuit. So I'm going to go through each resistor and measure the voltage drop across each one, and you should see that they all should be around 5 volts. Once I had measured the voltages, I put it down here to get a better visual of the circuit, and then I rolled into measuring the current. So once we had measured the current across each resistor, we compared it to the calculated values. So as you can see, the values differ a little bit between the measured and the calculated. Well, that's it for this video. If you guys enjoyed it, please subscribe. And if you would like, check out our previous video. And I'll see you guys next time.